The fifth team to present is Team Water Begone from USM. The floor is now yours. You may move to the front and begin your presentation.
Thank you, Speaker of the Hall. Assalamualaikum and very pleasant morning. I bid our fellow judges, participants, supervisors, and also all the audience that attend today. We from Team Water Begone, which consists of myself, Aizat Muhammad Aminuddin, and my colleagues, Nur Adibah and Nur Shaza from University Science Malaysia School of Chemical Engineering, will be presenting on water resilience coating generated from oil palm ash waste as a preparation for flood. So in Malaysia, flood is one of the major natural disasters that occur yearly. So last year in Kelantan, the Kelantan flood disaster is regarded as one of the major or the worst flood that occurs in Malaysia. It has caused the government to spend millions of dollars in order to replace the cost due to damages in vehicles, houses, and also furniture. So in order for us to prevent such things from happening again, our team proposes that we do a super hydrophobic surface where it is developed by the utilization of agriculture ash. Super hydrophobic surface has three main properties, which are ability to repel water, anti-fouling, and also self-cleaning.
Okay. For your information, a super hydrophobic surface can be obtained by modification of the silane and the agriculture ash via silane treatment. Okay, there are 4 steps in silane reaction. Firstly, the silane is prepared by process of hydrolysis and condensation. The chemical group R, such as CH3 and CF3, are grafted onto the silane. Next, the silanol group of the silane will be bonded together with the OH group of the ash by hydrogen bonding. Lastly, with the loss of water during drying and curing, the covalent linkage will be formed with the substrate. Okay, now let's see the 3 levels of hydrophobicity. Okay, first, this flat surface shows the hydrophilic condition. Next, the Wenzel proposed this condition as hydrophobic condition. And lastly, a super hydrophobic condition can be shown in this Casey-Baxter model. Okay. A super hydrophobic condition occurs because the ash particles has OH sites that can provide chemical grafting and roughness on the surface. So there will be spaces of air exist to avoid the contact between the surface and the water droplet. Moreover, this is our desired outcome. Hence, we can say that through modification of the silane and the agricultural ash, we can obtain a super hydrophobic surface.
So audience, do you know where do we get agriculture ash? So palm oil industry is a major agro industry in Malaysia, and it has produced a lot of solid material. According to agency University Malaysia, palm oil fuel ash according to agency University Malaysia, there's a lot of waste has been produced. So we want to convert the palm oil waste to palm oil fuel ash. So
actually the slides is disturbed a bit, it's missing. There's supposed to be a slide behind this. Actually this is a video that shows the difference between a super hydrophobic surface and a slides where it is not coated with super hydrophobic surface. So it can be seen by the slides that we given. So if you dip it into it, you can see the difference of the 2 layers. Okay, so in the future we hope that the palm oil fuel ash can be used for the super hydrophobic coating. because it can reduce the landfill. It also can convert waste to gold, improve management of flood disaster, and also improve the sustainability of palm oil industry. So imagine if there is 90 million tons per year of waste, palm oil waste, so how much super hydrophobic coating can we produce? With that, we thank you and open the floor for any inquiries.
Meaning that no damage at all. So reducing it, maybe I see it. And you see it's workable, not expensive. Huh? Workable lah. I mean, you have calculated that. Okay, thank you.
Yeah. Again, good idea. What I'm thinking, first of all, is this invisible? I mean, if you're going to spray your furniture and your house, is it completely invisible? And what feel does it have for applicational purposes?
Actually, we can adhere the coating to paint as well, so it can change colors. Right? You just adhere it. It's, according to the slide, it's not very visible.
I mean, from looking at this, the white part here is the coating, right? So basically everything you sprayed on will be white or some other color.
Yeah, it's almost transparent.
Okay, so is it a liquid or is it like a because this one feels a bit like it's a bit rough, solid or.
We spray it, it's liquid, and then we let it dry, just like a paint.
Okay, so basically that you can't see any difference on the surface after you sprayed
almost
on.
no difference with the
Okay, okay.
Otherwise, people don't want to use it.
Yeah.
People have expensive furniture and expensive car. So I suppose that it might be some here and doesn't change the other thing. It might be the same.
But it is a bit rough, right? I mean, the rough surface is your coating on this one.
The rough surface is what make it super hydrophobic.
Yeah, exactly. But that means your furniture will have this rough surface if you spray it on to the furniture.
Oh, probably.
Yeah, okay. And another thing, I'm not quite sure how you're going to reduce the waste. Now you have a lot of EFB lying there. This is produced from the ash, and you're not going to burn things just to produce ash. You're going to burn for some other reason, for electricity. So again, I think your material is using the waste, which is the ash only, but you're not actually reducing the amount of EFB, are you?
Because
waste?
we burn all the EFB and the trunks and everything, fronds, into ash. We burn everything into ash, and then we utilize that ash for the super hydrophobic coating. And then we can reduce, indirectly reduce also the landfill.
Okay, but I think maybe there's more economic ways of using the residues than this, and then use it for some other purpose, and then take the ash after you create energy of something. So the main investment would be to use it for something else, and then you use the ash waste product from that use for something else. So you have to combine your efforts with a power producing plant or something. Yeah, exactly. Yeah. But it's interesting. But yeah, you're gonna need to look into more details, as mentioned by Prof. Sharifa as well, on how does it actually help. Conceptually, yes, I can see it can help on some things. But one thing is that you're actually putting a surface. How to get the surface off again? I mean, are you gonna have to have your furniture can have this for the rest of their lifetime? They're gonna have this coating on it.
Pieces of coatings are already in the market. Okay, you can buy in a supermarket where you have this. Where you put on your cars, the rain just wash off. Okay, so in terms of the ash, you are not going to burn specifically for ash. If you go to the mill, palm oil mill, you have ash already from the boilers, and that at the moment is a problem to us because we need to dispose this ash. If you have an application that uses this ash for some other value-added product, it would be a very good proposition for us. But you should be looking at this product for industrial application, not so much in terms for flood. But preparing for flood, I don't think it's going to work. You have to look at it for industrial application, for example, coating on roofs, coating on buildings and all that, or machinery where it's exposed in the open. So you should be looking for this application for industrial application.
Yes, fully agree with Tuan Haji that you should be looking into industrial application, anti-rust, anti-corrosion. I think that would be the area where you can focus on. Because looking at the flood, you know, in Kelantan last year, the houses that were damaged were people who lived, not very rich people, you see. They won't be able to afford it. Thank you.